Okay, so opening up here, real quick, I'm gonna be 100% honest. And sorry for my language, but this unit scared me shit. This, this is a very daunting unit. But I think we can do this. As my calculus teacher used to say, just hold my hand and we'll get through this. But uh, this unit really made me like reconsider my life decisions and everything. But that out of the way, let's begin. We won't be looking at much raw statistics in this one because honestly, it's so many formulas and different things you have to look at that if we look at both raw statistics and how to use SMW or how to use anything, it's gonna confuse the hell out of me and I'm gonna confuse the hell out of you. So I'm gonna keep it short and sweet. Um, no raw statistics this one. Just in a pen, just straight formulas and just trying to explain as much as I can. How I would understand it. But yeah, please, in every single one of the modules, I'm telling you guys, just take everything I say with a grain of salt because I am, at the end of the day, not a teacher. I don't get paid for this, so um, there's a very high chance I say something that's not right at some point during any of the videos. So review on your own. I'm just trying to get you up to speed the way I study. So yeah, but let's begin. So first we're gonna see. So the first video we're gonna mostly see, or we're gonna exclusively see t-tests for means. For means, because if we look at proportions as well, your mind's gonna fry. Mine almost did. Uh, Independent t-tests for no no no. This is paired t-test for means. We're gonna look at independent means confident, and we're also gonna see paired uh confident means confident. It's not going to be in this exact order. I'll make sure to label them as best as I can. Uh, but yeah, so again, I'm basing a lot of what I do, or literally everything I do. It's just running through examples that the teacher gave us, and I'm trying to explain as best as I can. So the first thing we're going to do is, and we're just going to load up. Wow. Am I connected? Did I do that same mistake again? Wait, I'm gonna pause it now. Get everything up and running. Okay, so everything's up and running now, and we have our first um thing we're gonna look at. We're gonna use the truancy dataset, and I'll just copy the questions over. So the first thing we're gonna be looking at, this is a question, by the way. Um, it's this one here. Is there any statistic significant difference? So we're mostly looking at this one as a paired test. The way you can know that it is paired is that we're using the same test subjects in order to compute the test. So say you have Charlie. This is a kid, right? And you want to measure his um, output, his happiness before and after eating chocolate. So you have Charlie, you have him existing, you give him the chocolate, you give him the chocolate, and now you have post chocolate Charlie. Um, so yeah, he's probably gonna be happier. I don't know. Um, but the thing you can take away from here is that this is paired because you're still using the same subject. If it was independent, you'd have like two different kids and you'd run different tests against them. Like, but these kids have to be completely unrelated. but that's a way of how to distinguish between paired or independent tests, whether or not you're using the same test subjects. That's how I know it. But again, do your own research, just to make sure I don't confuse you guys. So here, essentially what we're looking at is the statistically, if there's a statistically significant difference before and after the program. So it tells you you have your kids or like your people before and what happens after. And but you're still using the same people. So this can look at you can look at it two ways. So you have either that the null hypothesis is that the mu before is equal to mu after, or the alternative that they're different, or you can use like a zero in order to describe it. And why do we use zero? Because if you have mu before minus mu after, and you subtract them, and they're exactly the same, it's going to give you zero. So let's say mu before is 2, and mu after is 2. It's going to give you zero because they're exactly the same. But if one of these is different, say this one's 2 minus 3, it's going to give you that they're -1. Therefore, they are not different. So that is why that notation is there. So going back to our thingy here, we first need to actually find a difference. So how do we do that? So we add a column to our data frame of df, and you get the post percentage because you're measuring if something happened because of the experiment ran, and you also subtract it, or you subtract the pre percentage. I think it's PCT, and if you do df.head, you're gonna get that. You see, we now have the difference of our subjects before, after, and before the experiment. So what do we do next? So as in all of our previous examples, and again, there is no raw statistics associated with this one. There is a, and I'm sorry, I'm just deviating out of nowhere here. I'm pretty sure it's here. Yeah. So here you can see everything as the raw statistics formulas, but frankly, unless you have only the sample statistics in the exam, you won't need them. You will mostly be manipulating databases, I hope. So you do res equals smw dot, that's w. So you're gonna look at, and this is for a paired t-test. You're gonna use this for a paired t-test. You're gonna get the statistics of df_diff. So what do you do next? So I just went ahead and copied the formula from the formula sheet we have. So you're running a t-test, but as you remember from different or from previous examples, we have that our mu goes here. But in this case, we're looking at a difference, and we have that our null hypothesis states that the mu of the difference, mu of diff, is equal to 0, because that's what the hypothesis test is telling you. So then you just get your t-stat, your p-val, and your, let's not get the degrees of freedom, it doesn't really matter. Or like, I don't know if it matters. I'm not going to put it here though. So you get that your p-value, give me 1 second. I was still recording. Anyways, what I was trying to see, because this threw me off guard, the find a 95% confidence interval in the difference, because since we're doing hypothesis testing right now, I was like, why is there a confidence interval? So we're just gonna go ahead and ignore that. So that is how to do paired means hypothesis testing with SMW and using this formula here, which is the one we've been looking at. This is always going to be two-sided because since we're looking at a difference, I'm pretty sure it's always two-sided, but again, don't take my word for it. And yeah, that's how to get it. So continuing on, now we're going to look at independent means for hypothesis testing. Here in this program, in this problem, it clearly states to independent sample t-test because boys and girls are assumed to be independent groups because they have no siblings. But as you can see, you have two groups which you're getting means from. So this usually assumes independence, but again, do your own research and make sure it's clear in your head. So since we're comparing means, it is again the same one. So you can also write it down as U of boys minus U of girls equals to 0, and that U of boys minus U of girls is not equal to 0, which is the notation we used here. It doesn't really matter. Both are saying the exact same thing, so whatever's best for you, go ahead and do it. So the first thing we're going to want to do here is separate this by gender, because, oh, I paused my sharing. Whoops. So we're going to do this by genders. So you're going to do two new data frames. So you have data frame boys, and this is DF and DF. And you're going to say from the column gender, if this equals, or no, this would be male. Now that's your data frame boys. And if you do the exact same thing, but let's put this G. So let's put this F for female. You should have these work perfect. So let's quickly print this. So as you can see, gender male, 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 male. This is all male, and this is all female. So that's what you did here first. So then what you want to do, you're going to have boys, and you're going to get this, but only for the boys, because you're only looking at the male. So you're going to do SMW dot W. And since we're still trying to find the difference of the truancy reduction program, I think, I don't know what truancy reduction is, but since we're trying to find the difference within the same program, and if it affects different boys and girls, we're still going to use the column difference. So for, oh, sorry, I forgot a very key thing here. So you put the B here. So what you're essentially telling this is from the data frame only of males. So only of males. So this here, only males. Get the statistics for the difference column because we're measuring the difference. So you're going to do the exact same thing, but for girls. So you're going to just copy it over. You're going to change that to girls. You can name it whatever you want. G, girl, doesn't matter. As long as you separate boys and girls and their statistics. And then we're going to do, did I stop recording? We're going to do res equals dot smw dot compare means. By the way, I was going to pause it to get the formula, but I think I accidentally click stop recording. Hopefully not. If not, we'll just start over once I see the video. So we're going to do smw dot compare means, and we're going to do boys, girls. And then we're going to do the exact same test, or sorry, not the exact same test. This we're going to test the means. So you're gonna get p-val, and then you're just gonna paste this. This is in the formula sheet. So again, your mu is 0. I don't know what this does exactly, so I'm sorry I'm not able to explain that, but just copy and paste the formula, you should be fine. And if you do here, you should value error. What happened? Give me 1 second. Okay, so anyways, I fixed it, and yeah, so we have here our p-value. We have our p-value. So as you can see, I don't know if we established an alpha value, so um, I'm just gonna assume it's 0.05. But as you can see, this is anyways gonna be less than, sorry, our p-value is more than our alpha. Therefore, we're gonna fail to reject. And yeah, I'm just gonna show you the teacher's workings. So here are the teacher's workings. It's pretty much the exact same thing. Well, because I'm following her procedure. So yeah, you separate your databases, then you get the statistics for each column, you compare the means, and then you run your independent t-test. That's something I want to make very clear. You're going to use your independent t-test, and yeah, that's the first part of this. This is looking at tests, so like hypothesis testing and hypothesis testing of means. The only thing that changes, this is a paired mean and this is an independent. Processes usually go the same. There are probably a couple differences, but in its generality, if you follow this, you're gonna be fine. And next up, we're gonna look at confidence intervals. So this one's really interesting. We're not looking necessarily at a created database, or sorry, like an Excel database. The teacher gave us the database created in class. I'm guessing, I don't exactly remember, but we're not reading any CSV file or any Excel file. So here you can start reading. It's just comparing post-test and pre-test. So that tells us that since you're measuring an effect on the same group of people, it's a paired means confidence interval. So the first thing we do is we create the database. You rarely have to do it, if ever. It is extremely rare if we're made to do databases. And the only thing is this one, it's df.dropNA. So as you can see, you have NP and AN. So dropNA drops any missing data you might have. So the first thing you're going to want to do is get the improvement of these children. So you're going to start looking at their post-test grade, and you're going to subtract from it the pre-test grade to see how much they improved. So let me just clear my annotations there. So you're going to do df improvement, and you're just going to do equals df post-test, if that's the right way to spell it. It is, minus df dot pre-test. Pre-test. No, that's not pre-test. Let's make sure that's correctly written because it's been I've been making that same mistake quite a bit. And we're just gonna run our data frame. So now we can see improvement. So you see there's 48 minus 40. It's gonna give you 8. So perfect so far. So as has been the mode through everything we've been doing, you just seeing me put rest, you have to start assuming what I'm gonna do. So you're gonna do this stats W, and you're gonna get it from the improvement. So once you have that, easy, simple, just this is your formula. Since it is a 95% confidence interval, if it's it was in the teacher's notes. I'll show you guys later. But this is we do lower, upper equals, and this is your res t-test confidence interval of means. And then you're just going to print comma upper. And yeah, there you have it. So why is that negative? I'll explain once I'm in the teacher's notes to make sure I did it correct. So yeah, it gave a negative answer to the teacher. I'm pretty sure this means that there were some kids whose pre-test was better than their post-test. But what we can say about this 95% confidence interval is that we are 95% confident that the true population mean of the improvement post-test uh, after the pre-test, or just the general improvement, is going to be between negative 0.26 and 11.06 points. And yeah, that is how to do paired means confidence interval. So in this one, we're going to start on the teacher's notes. So we're looking at Prairie Flour cereal. They have two machines. They package 510 gram boxes of sugar-coated wheat cereal. So, oh God, what was the name of the cereal I used to eat as a child? Mini Wheats. I think that's what they mean. Or like Quaker Oats, the squares. I don't know. Um, so you have here, you're trying to find the the difference in mean weights of two machines. So you know you have two, in this case, things you're measuring over the same thing. So you're not applying any process. You're trying to see the change. You're not trying to do that. You're just trying to compare two different things. So that tells us that this is a independent confidence interval. So the first thing we're going to do, if I haven't copied it already, no, I haven't. I'm just going to go ahead. That's not going to work. It did. Oh, that's amazing. It usually never works first time. So once we have that, and we're gonna go back to here, you know you're getting, by the way, I tried to pause the recording and I ended up stopping it altogether. So yeah. I don't think you guys will notice that though. So you're trying to find uh the difference in means, but there is no like first step. So the machine's information is not like together in the same database. So there's no need to do like the df bar df if like say machine equals you do machine one. There's no need to do this because in this case the machines are separated. But don't assume that just because it's on this one, it's going to work the same in any other. You have to use the process we saw here in this one. You usually have to separate the variables you're trying to find, but in this case, luckily, we already have them separated. So what is our next step? We're gonna do machine one equals res, smw dot stats, and then we're gonna do, just let me, yeah, sorry. I was making sure I was actually recording again. And here you're gonna do df, if this will let me type, df dot machine one. Thank you. Always delete the second one if you're gonna autofill, because if not, it will delete both, and it's just a pain in the ass. And then you're gonna do the same thing. Oh, I forgot the W here. That wasn't gonna work. So you're gonna do df, and here you're gonna say 2. So once you have that, you're gonna do equals, and you're gonna say here machine 2. So let's make sure we got the lower cases and upper cases. Okay, and then we're just gonna paste the formula from the formula sheet, or you can actually just copy and paste them from there. So as you can see, this is a confidence interval for the difference, and then you just have to do lower, upper, and that's not working. Why are you not working? Machine 2, is this case sensitive? It is. It's not necessarily case sensitive, but it is space sensitive. And there we go. So we can now say, and as you can see it here, that we are 95% confident that the difference between the packaging amount of the two machines is between 5.04 and 9.36 grams, I think. That is more of an interpretation thing. Just tried to get it within saying we are 95% confidence that the difference between the machines and yada yada yada, but then any units you're gonna use, that is based on each problem. So that was the four main types uh, of tests you can do with means. Of course, you have them here as well. So you have your so for t-test, you have paired and independent. That's what we were looking at right now. So as you can see, you have your, first, can I move this out of the way? Thank you. So you have here all your formulas, how to get different standard errors. Honestly, I'm hoping we're not going to have to do this mid-test because I don't see myself doing that. And hopefully you guys don't have to see yourselves doing that. But in any case, the formulas are here, and I wish you guys good luck if we only get the sample statistics. But I don't think we will. I think we're just gonna have to where's my delete thing? Here you are. We're just gonna have to use SMW, and if we actually have to do the heavy raw statistics, well, that's us done. But yeah, in the next video, I will do for proportions.